All right, continuing. Chapter 6. Static addressing. Newton, right? That's manually going to each computer and putting in the IP address. What else, when we statically assign, are we going to put in? The IP address, what else? Subnet mask, which does what for us? Network and host portion. Guess we didn't have everybody. You can also have the default gateway. What's the default gateway? The router, specifically the internal one here, but how we get out of the network. If this is misconfigured or not configured, can we get out of our network? No. Absolutely not. Can we hypothetically communicate with devices on our network? Yes. Hoo-yeah? All right, now, for assigning static IPv6, we'll show you on Monday how to get into that. But here it is. Use the following. That's our static IPv6. We put in our IPv6 address, and then our prefix. Well, IPv4 had subnet mask. IPv6 has prefix. The prefix for IPv6 is the same as the prefix for IPv4. What does it do? Same purpose. The network and the host portion, right, or which network it belongs to. So IPv6 doesn't have a subnet mask. It just has a prefix. But how many bits are for the network? Cerna?
Oh, so it would basically just be the amount of bits that are turned on?
Bits that are turned on for the network. Bingo. We've got our default gateway for IPv6, which is the same thing as it is for IPv4. The router of how we get out of our network. Hoo-yeah? Awesome. Now, obtain an IP address automatically. We have that for IPv4 and IPv6. Before we do that, questions?
Okay, so for IPv6, when you do the prefix and it's like compressed, those zeros still count towards the prefix?
They do, yeah. So even if it's compressed, right? 2001 DB8, what's in front of that? A 0, right? So you'd have to uncompress it and count those 64. Is that what you're going to ask?
What?
Right here, Garner.
Obtaining the IP address automatically, it's just using the DHCP to dynamically assign it?
Correct.
So for the subnet prefix, you have to assign yourself?
Yeah. All right, so let's say I've got this as an IPv6 address, /64. Let's figure out what's the network and what's the host. So we got to uncompress this first, right? 2001. What's this going to be here? 0 DB8, 000A, 000B, 000C, 000D, and awesome. So let's find this 64 for the network. How many bits are here?
16.
4. Here is 8. Here is 12. Here is 16. So this hextet, this whole thing is how many bits? 16. This right here would be 32. Here this would be 48, and this would be 64. So this here is our network portion. And then this would be our host.
So is there going to be scenarios where you're going to have to basically change it from each way to each way?
Let's see, what if it was 60? How many are here? 16, 32, this is 48. How many are here? There's 4 here, so 48 plus 4 is 52. This is 56, and this is 60. All right, so this here is our network. There you go. Yeah, in that situation, right?
So it's based off of whatever that slash is.
Yeah, the prefix, right?
Is that the subnet prefix?
This is the prefix that identifies what the network is. Just answering somebody's question from earlier. Yeah.
How would you know if it's 60? Like,
Because it gives it to you.
So we would see it like that?
Yeah. You need this to solve for this. You can't solve this unless you have this.
What if you don't have that?
Then you would have it, right? You've got to have that. Yeah.
So to be the network, it has to be right at 60 or over 60 or under 60.
It's got to be 60. That's subnetting. We're not there yet. I was just answering somebody's question from earlier. Don't worry about this. I was just answering somebody's question with an example.
Quick question.
Yeah.
What's the subnet prefix?
The prefix identifies the network portion, right? What's for the network and what's for the host. What we just did.
So the prefix is the subnet prefix? Or no?
Prefix is one thing. Subnet mask is a different thing.
Okay.
Subnet mask for IPv4, prefix for IPv6.
What is a prefix?
A prefix is how many bits are turned on for the network.
So they're kind of the same thing.
Yep, and then the subnet mask is just it in dotted decimal.
say that prefix is more or less shorthand.
Yep.
You just said that there's not subnet prefix.
Yeah. Yeah, if it's a /64. Yeah, yeah. Let's move on. Let's move on. We've gotten way off track. But going back up. So that was static, right? If I do obtain an address automatically for IPv4 or IPv6, what protocol is that using? DHCP. For DHCP, what are some things I'm going to automatically get? IP address, subnet mask, default gateway, potentially DNS as well. So what's the purpose of my subnet mask? The network and the host, right? Well, what's a prefix? The same thing, right? Which does what? Network and host. What's my default gateway that DHCP will give me? The router, how I get out of my network. What's DNS do? Translates URL to IP. Okay, what's the port number for DNS? 53. TCP or UDP? Both. DHCP, what are the port numbers for DHCP? 6768. Which one's for server? 67. Client? 68. That works for DHCP v6 as well, with 546 for client, 547 for server. All right, now let's scroll down. We're just repeating what we've known. So if we scroll back up, right? What does DHCP give me? It gives me an IP address. It gives me a subnet mask. What's my subnet mask do? Network and the host. But IPv6 doesn't have a subnet mask. What does it have?
Prefix.
A prefix. Not a subnet prefix, just a prefix. And what does the prefix do?
Identifies the network host.
Same thing as our subnet mask, right? Network host. Our default gateway. What's our default gateway? Our router, which is how we get out of our network. If it's not configured or if it's misconfigured, can I communicate outside my network? Can I communicate locally? Yes. It might also give you your DNS. What does DNS do? Translates URL to IP. Port number? 53. TCP or UDP? Both. Abdul Shakur. I am seeing what I think is the issue. Prefix. One word. Subnet mask is the other thing, right? They do the same thing, right? Like a prefix of 8 for IPv4, 8 bits turned on for the network. The subnet mask, we convert that from binary to decimal, which is 255.0.0.0. Prefix, subnet mask. Good? Good? All right. McCants?
No, I only got confused because of bullshit over there talking about doing subnet prefix.
Language.
I said a bullshit.
Oh, I thought I heard a different word. Never mind. Good. Never mind. Are we good? Everybody's good?
Yes.
Okay.
Yes.
Moving on. Moving on. Awesome. So we've seen this. We talked about DNS. We talked about DHCP as port number 53 is DNS, translates URL to IP. DHCP is 6768. Which one's for server? 67. Which one's for client? 68. This works for DHCP v6 as well. 546 client, 547 server. Now, what protocol allows me to type in Instagram.com instead of an IP address? DNS. What's the port number? 53. TCP or UDP? Both. We're getting it now. We already talked about some of the records for DNS, right? Like which record is for IPv4? A. A is for IPv4. What's for IPv6? Quad A. A. What's for email servers or mail exchange? MX. Text? TXT. Authoritative name server? NS is for our authoritative name server. That's one we're going to add in CCNA. So the only thing different here for CCNA is we're going to add NS. Hoo-yah? All right. Now, if we scroll down more, spam management. This is the third time we've seen all of this stuff. So instead of me explaining it, we're going to watch a short video.
Process of establishing the identity of email senders. This helps domain owners confirm the legitimacy of messages sent from their own domains. By authenticating emails, you can easily distinguish between real and fake messages and even prevent phishing attacks. But do you really need it? Let's discuss the horrors of unauthenticated emails to understand why. Without authentication processes in place, your domain name is prone to impersonation and spoofing. Spoof domains can be used in phishing campaigns to steal login credentials and spread ransomware. This can seriously harm your online reputation. The basics of email authentication can be covered by implementing three primary protocols: SPF, DKIM, and DMARC. SPF is used to define a list of authorized senders for your domain, while DKIM adds digital signatures to your message content to prevent tampering. DMARC allows domain owners to make policy-based decisions on how to treat emails that fail SPF or DKIM. With DMARC, you can instruct your receivers to discard potentially malicious emails. Hence, authenticated emails have a lower risk of spam and enjoy higher email deliverability rates. PowerDMARC specializes in email authentication configurations. We have helped thousands of businesses across the globe set up and manage email authentication for their domains and customers. Along with hosted services for DMARC, SPF, and DKIM, PowerDMARC also helps businesses configure additional protocols for authentication, like BIVR, MTA-STS, and TLS-RPT. Our goal is to make email authentication accessible and easy for all.
All right.
Check out our services.
So hopefully that's a little better than me just repeating the same three things about those again. All right, moving on. Why and two? Yeah. But for the email server. And you've got on your CAT card an email certificate and a logon certificate. So that email certificate authenticates you to the email server. All right, question? You want your screens back? Go in here. Click here. Click here. Click end. Go back full screen. Click here. Click, yeah. All right, what protocol allows me to automatically get an IP address? DHCP, port number 6768. Which one's for server? 67. Which one's for client? 68. That process, there's 4 steps. What's the first one? Offer. Who ya? Our layer 2 address, aka what? MAC and physical. My layer 3 address is aka logical. All right, so the first discover message. Well, hold up a second, right? Slow down. I know we're excited because we're remembering this, right? Hopefully? Okay. So our discover message, is that from client to server or server to client? Client to server, which means it's what port? 6.7. Our layer 3 address now, is that a unicast or a broadcast? Broadcast is 1 to all. Well, let's do all of them now. Unicast is 1 to 1. Multicast is 1 to many, but not all. Broadcast is 1 to all, right? So this is a broadcast. The offer, is that client server or server client? Server to client, which means the port number is 68. That layer 3, is that a unicast or broadcast? Broadcast. The request, now that is from who to who? Client to server, which means the port number is 67, and that is also a broadcast. And the acknowledgement is server to client, which means port number 68, and that is also a layer 3 broadcast. Now, after all that's done, finally you'll have an IP address, a subnet mask, etc. And that's why layer 3 is all broadcast, because it doesn't know who to send it to for the IP address, because you don't have an IP address until the whole process is done. Remember, you can't go exploring on the internet until DORA is complete. Good? But our layer 2, our MAC address, the discover, is that a unicast or broadcast? Broadcast. Our offer is unicast. Our request is broadcast. And our acknowledgement is unicast. We're starting to remember this? Awesome. We're going to do this again when we get to CCNA. Cerna.
So when it's a Mac, is it unicast when it goes from server client because the Mac server?
Because that's a unique to, we used Watkins as the example, right? So he says, hey, is anybody out there? I need an IP address. But when he sends that message, he's already got his unique MAC address to him. So when they respond, they don't know which IP address to send it to because he doesn't have one, so that's a broadcast. But they know the layer 2 address to send it to because he has a unique MAC address. So that's a unicast back. We'll talk more about that in CCNA. I can't hear you. Say it again.
If you had a
Sorry.
request going out for an IP, and say for instance you have AT&T, would that be going to an AT&T DHCP server to get that IP address, or is it like specific? Is it just like any?
Typically, DHCP is going to be built into your internet service provider, like AT&T's router, and you won't have to do that. They'll have it pre-configured. Yeah. But some of them, they will allow you to change your settings, but more and more common, those are settings you can't change for a typical user. We good on Jackson?
I'm good on doing it, but what were the port numbers for the DHCP for the IPv6?
DHCP v6 is for IPv6, and that is 546 and 547 for the server. That's DHCP v6, which is IPv6. 7 server. This is DHCP v4. In ITE, we're not going to get into DHCP v6. But it is the same thing. They just call it something different, and there's something a little bit different after that, but we'll get into that well into CCNA. But for CCNA, for DHCP v4, we're going to do this exact same thing, and we're going to teach it the exact same way. So you're already DHCP for CCNA, ready to go. So we just added a few things here, so that way it's just the same. Good? So instead of doing 70% now and 100% later, just 100% both times. Good to go? All right, so at the end of DORA, you get an IP address. What else do you get? Default gateway, subnet mask, of course, and maybe a DNS server, right? Okay, but that's a lease. You don't have that IP address forever, right? But, so if you need to renew your lease, does it do the whole DORA process again? No, right? You signed a year lease at your apartment, and your lease is almost up, and you know you're going to stay there. Are you going to go spend your time going to all these different apartments, touring, etc.? No, you're not going to broadcast that out. So it's just going to be, for renewal, it's going to be request down, right? But because you've already established that communication, these, for the renewal, are going to be unicast. Everything will be unicast for the renewal process. But these will be the same too. To renew your lease for your IP address. Let's say you've got a 3-day lease on your IP address. It's 2.5 days in, your IP address is going to expire in 12 hours. So it's going to say, oh, you know what, hey, DHCP server, I need to keep using this IP address. You'll send a DHCP request, unicast to that server, and it'll say, oh, yep, here you go. You can just have that longer. I'll update that's being used.
Is that being done automatically as well?
That's being done automatically. You've been using DHCP probably your whole life, and this has been going in the background without you knowing that it's happening.
What determines if you make your own IP address versus?
What determines it? Well, that is in your settings, and we'll look at these later, but when you go into your settings for IPv4, DHCP is this first one up here, obtain an odd IP address automatically. If you want to statically configure it, you would select this here.
And that's more complicated, like CCNA stuff.
Kind of. We're going to do it in here later on Monday. And then in Chapter 7, we'll go over mobile devices, how to do it. Good? So for those of you who felt 5 was overwhelming, right? Notice we just did the same thing we did in 5, right? And now we're getting it, hopefully, right? So don't get yourself down. Think right now, how much of this stuff is hopefully clicking for you, right? And think, okay, we learned this in Chapter 5. Oh, Chapter 5 is hopefully clicking, becoming easier for us now. Easy day? All right, moving on. We talked about Wireshark already, so we can go past that. We talked about the renewal process for request and acknowledgement. We'll keep going down. VLANs. All right, we talked about VLANs. This stands for virtual LAN. This takes the same LAN like in here and logically in software separates it. Why would we do that? To segment it, right? For there to be less traffic on the network and for security as well. So those IoT devices are on a separate VLAN. Maybe if we have a human resources and a sales department, human resources with all of our employees, PII, banking account information, etc. It's on a completely separate network over here. Good to go? Now, if we scroll down, this is CCNA 2 stuff. If we scroll down more, where you're configuring it. We're not going to talk about this because you don't learn this until CCNA 2, but these are the commands to do that. But we haven't even talked about the modes of a switch or how to even get into a switch yet, so we're not going to talk about that. Good? Say again? Correct, yep. VLANs make sure security that only those devices can access certain things. Good to go? All right, if I'm configured to use DHCP, if your computer is configured to use DHCP, you send out and you start the DORA process, but nobody's out there, nobody responds. Your computer still needs an IP address. What IP address is it going to give you? It's going to be a link local. It's going to give you an automatic private IP address. And what does that start with? 169. 254. Whatever. Could be 01 all the way up to 255, 255. So that's in the PIPA, automatic private IP address. And it's also referred to as a link local. That means that IP address you can communicate locally on your network, right? Link local, locally, but can you communicate remotely past your router on remote networks? No. All right, with me there? Okay, that's obviously not a good thing. Now, there are so many IPv6 addresses that your computer is going to have two of them. It's going to have a link local address to allow it to communicate locally with devices locally on the network. And that's going to start with FE80. Is that first hextet? That's all you care about. Now, if you're going to get a cert or something like that, it does go up to FEBF. Right? But for us, for this course, if you're not worried about certs, etc., FE80. Good? If you want to get the certs, you want to know the technical answer, that range does go up to FEBF. I'm going to erase this because this is probably too much. If you're struggling, for this class, you do not need to know the range. You just need to know this. If you're struggling, you feel like this is a lot, ignore this. Yeah.
So would a reason that you can't connect or like find an IP address could be something with your computer, or would it be something?
It could be a plethora of things. Maybe your NIC is bad. Maybe the cable's loose. Maybe the DHCP server is down. So that's when you would start troubleshooting. Question in the back? Well, IPv4 is in dotted decimal. IPv4 is just numbers. FE80, this is just IPv6. Our link local for IPv4 is 169.254. Our link local for IPv4, 169.254. But that's a bad thing for IPv4. Roberts, is that a hand? Okay. All right, you're also going to have a global unicast address for IPv6. And that's how you can communicate publicly, remotely, etc. And that's going to start with 2001. That's also for IPv6. What is it for IPv4? Well, it's anything that's not private. And we talked about that when we went over classful IPv4. So in IPv4, link local, is that a good thing? No, you see in a PIPA, ooh, you can't get on the internet. You've got a problem, you've got to start troubleshooting. In IPv6, it's a requirement for you to have a link local address so you can communicate with devices on your local network. Good? We need more time to write? Okay.
The FE80 and the 2001 are the IPv4, right?
IPv6.
Oh, IPv6? Is that for IPv6?
This is IPv4. So the link local for IPv6 is so it's going to use that address to communicate locally. The global is what it'll use to communicate remotely.
For IPv6, right? If you use DHCP, will it automatically give you a link local too?
Yes, and we'll talk about that in CCNA. It's going to use for both, but we'll talk about that in CCNA. So static or dynamic, you'll have both. More time? We ready? All right, quiz. Let's see what we know. If you scroll down and then click it, it'll go, there you go, like that. This address is analogous or similar to a fingerprint. MAC address, aka physical address. This address does not change when a device moves to another network. MAC address. Now, if the packet moved to a different one, the MAC address changes. Whoa, look at this, 0050.56BE D787. Let's pause here for a second. What do we think this is? MAC address? Could it be an IPv6 address? How many bits are in a MAC address? 48. How many bits are in an IPv6 address? 128. So this is 0050.56 BE D787?
Yes.
All right, how many bits are here? 4. This is 12. This is 20, 24, 28, 32, 36, 40, 44. This is 48 bits written in hexadecimal, so this is a MAC address. All right, next. This address typically changes when a device moves to a different network. IP address. All right, 192.168.200.8 is what? IPv4. All right, let's go back up. Oh, here, let me correct you real quick. Good? A 32-bit address represented in dotted decimal. What's that? IPv4. Because IPv6 is hexadecimal. How many bits? 128. This link local address is an APIPA address assigned by Windows. IPv4. And that's not a good thing, right? No. Can I get out of my network? No. Can I communicate locally? Yes. Hypothetically. All right, 2001, DB8, 1111, D787. What's that? IPv6. We're getting it now. This link local address, a 128-bit address that is represented in hexadecimal. IPv6. This link local address is required by every device on the network. IPv6. It's a requirement for IPv6. Bad thing for IPv4. This automatically assigns IP addresses to a device. DHCP, port number 6768. 67 is for server. 68 is for client. This is used to identify the network on which the computer is located. Subnet mask. For IPv6, it would be the prefix. This identifies the router the device will use to access the network. Default gateway. This statically assigns IP addressing to a device. Network administrator, that's going to be you. Hit submit. Question?
I seen that they, for like the, what is it, the,
Scroll back up.
wait, up a little more.
Up more. Up more.
Oh, for the MAC address,
Yep.
they use periods instead of that always true?
So MAC addresses, that's a great question, right? IPv6 is going to use colon and double colon. Well, we can only use one double colon. Your MAC address is going to use periods, or what we call in the military a tack, or a slash, right? Or a dash, depending on the operating system. So that'll be the MAC address, period, or the tack. Good? All right, any other questions? Yeah.
The Mac can't use the double colon, right?
Macs don't even have colons. Yeah. Period or dash tack. You can't compress your Mac. You wouldn't compress your Mac. And we'll learn more about why and how that works later.
When it's already assigned like that, because that's how it gets assigned to you, right?
We're going to dive into that later, the different ways to do it. Good? All right, next. 612. We are going to do our first packet tracer. Packet tracer is a software that allows you to work with computers, kind of, switches and routers, mostly, etc. So here we're going to learn how to configure IP addresses on a device. So I'm going to run you through what packet tracer looks like, how to navigate through it, how to see the instructions. I'm going to demonstrate the packet tracer you're going to do, and then I'm going to have you all do your packet tracer. When we do this, this is not time for a break, right? In fact, I'm going to be walking around. Help each other out. Help your shipmates out, etc. Easy day?
I was having some issues like clicking some of these at home because I got like an old piece of junk computer. Is that like something I can...
You've got to download packet tracer first before you can do this. Okay. Yep. But you're not really going to do that till CCNA, and I'll demonstrate it then. All right, so if you navigate to 612, this is a packet tracer. On the left, if we click that, that is the instructions. We don't really need that. What we need is this icon here. If you click that, it'll download it to the computer, and then you can click Open. When you do that, packet tracer will begin to load. If you click this, behind here is the activity, but we have to first log in. So I want you to click the Keep Me Logged In for 3 months, so that way you don't have to log in every single time. So make sure you click that, and then log in. That'll bring you to Cisco, Netacad, but if you've already logged into Netacad, you'll be good to go and you're logged in. If not, log in with your Netacad credentials. Log in. Once you do, you can close this, and packet tracer is loaded. If a pop-up comes up and asks if you'd like to start multi-user, you can click yes, you can click no, it doesn't matter. So here we've got 2 things and 2 tabs down here. I've got my packet tracer here, and then I have the instructions here. What I like to do is click dock, and that'll put it here so it's all in one tab. And then I can choose how much room that this takes up. Everyone see that? All right, well, I can scroll here and see all these instructions. Then I have my completion at 0%. As I complete things, this will go up or down if I do something wrong. You can click check results to see what you're missing. However, when we do graded things, you won't be able to see what you've got wrong. So let's walk through what this is going to do. Now, since this is the first time we're doing packet tracer, this is our logical workspace here on the right. If I click down here, I've got network devices, and that changes this icon here, because then I can choose routers. And I've got all these routers over here. Here we've got switches. If I click switches, that'll change here the switches. If I choose hubs, hubs. If I go back to the main category, instead of network devices having routers, switches, hubs, I can choose end devices. Then my options down here change, and I can choose PC, laptop, and these I can drag and drop onto the workspace. We also have connections. So I can choose a console cable, straight through, crossover, things we're all going to get into later. Booyah? Awesome. And we'll run through this again when we get to CCNA. But for now, here are the objectives. Configure the computers to use DHCP. Configure static addressing on the server. use ipconfig to retrieve the host IP information, and use ping to verify connectivity. Questions? Okay. Here's a hint, which we've already done. We've hit top and dock. This is an introduction, and here are our instructions. Part 1, study the topology. The topology shows two PCs. Here they are. There's one here and another here, PC0 and PC1. There's a switch, which is this right here, right there. We have a server right here. We have a router right here, and a cloud right here, corporate. It says notice the PCs are connected to the branch switch here using a straight through cable, right? Because unlike devices, straight through. A crossover would be a dashed line. It says notice the green triangles on each side of the links. That means that they are communicating, they're up, etc. Good to go? All right, so part 2, that gets into our first part of our instructions. It says click PC0. So what I'll do is click PC0, and then this pops up. Next, in the PC0 window, select the desktop tab. If I want this to stay up, I can click top, and it'll stay up there. So click the desktop tab, that's up here. We have physical, config, desktop, programming, and attributes. We'll click desktop. Then it says click the IP configuration. So we'll click that. And it says select DHCP to enable it to operate as a DHCP client. Click that. It's requesting, and it was successful. Look at that, 172.16.1.1. Subnet mask to identify the network portion, default gateway to get out of the network, DNS server to translate URL to IP. Now, if DHCP didn't work, what would my IP address here be? What would it start with? 169.254. It'd be in a PIPA or link local. Hooyah? Says we should see the following message, that DHCP request is successful. We do indeed see that message right here. Close the PC0 configuration window by selecting the X in the upper right-hand corner. Close that out. That closes desktop, the IP config. This X closes out the entire thing. It says repeat the same steps for PC1. And that's how Packet Tracer will run you through. It'll go very detailed what exactly to do. And then it says do the same thing for PC1, but it won't tell me the steps. Cerna.
Why would the IP be 172.192?
Why would it be this instead of what?
192.168.
Remember 192.169.254? That's a PIPA, right? That's if I'm configured for DHCP, but I can't communicate with the DHCP server. So let's see, if I delete this cable, and now try to do DHCP, this should fail. It's not even going to do that. But it should fail, right? Because I can't communicate with the DHCP server, and it'll give me an IP address of a PIPA, 169.254. Good? All right, so let's go back and let's do DHCP on PC1. That'll eventually be successful. Let's fast forward time. There we go. Good. Repeat the same steps for PC1. So we'll click PC1. And if you don't remember the steps, go back up here and look to see what the steps were. Just change PC0 for PC1. So what am I going to click? Desktop, IP config, DHCP. It's requesting it. Boom, successful. We got an IP address, a subnet mask to determine the network, default gateway to get out of the network, DNS to translate URL to IP. And we'll exit out. Easy day. Look at that, I've got 33%. And we go on to step 3. observe the configuration assigned to each PC. Step A, click PC 0, click the desktop tab. So PC 0, and we'll click the desktop tab. Then it tells us click command prompt. That's right here. And at the command prompt, enter ipconfig /all. So ipconfig /all. Enter. Then it says press the space bar to see all the information. See how it says more down here? It's because there's more. If I hit space, it'll do the rest. Hoo-yah? Now, my MAC address is going to be called what here? Physical address. And here is that MAC or physical address. Here's this IPv4 address, the subnet mask, the default gateway. And here's my Bluetooth information down here. Hoo-yah? Wants us to record all that information. So let's open up a notepad, or you can write it down on your notes. And let's do PC 0. And we'll do, let's see. It wants the IP address. So the IP address is 172.16.1.1. The subnet mask is a /24 or 255.255.255.0. The default gateway is 172.16.1.254. All right, we can see that here. And it wants the DNS server. So one more thing. Let's add that DNS server, which is down here, 209.165.200.226. Good? Repeat the steps for PC1. So let's close this out. PC1, how do I find my configuration information? Command prompt, and we type in /all. And let's record this as well for PC1. PC1, the IP is 172.16.1.2. And the subnet mask right below that is another /24, 255.255.255.0. Our default gateway is that the same as it was for PC 0? Why would it be the same? It's the same network, just like all of you in here. You got the same door to leave the room. DNS is also the same, of 209.165.200.226. Hoo-yah? Okay. Next it says use the ping command, test the connectivity between the PCs and the default gateway. So on PC 0, so let's go to PC 0. We're going to come here, we're going to go back to command prompt, and we're going to ping, enter ping, and then ping PC1's IP address. That means ping, and then we put in there PC1's IP address, which is this here. So ping 172.16.1.2. Does that make sense, everyone? I'm not going to type in ping PC1's IP address. No, we put in there PC1's IP address, which is, there we go, 172.16.1.2. Now that'll run 4 times. 1, 2, 3, and 4. That means that, hey, that device is on the other side. Hoo-yah? Hoo-yah. Just like when I say hoo-yah, you say hoo-yah back. So go back here. At PC 0, ping the default gateway. So let's go back to PC 0, and we'll ping the default gateway, which is ping 172.16.1.254. 1, 2, 3, 4 replies. So that's good. We can communicate to the default gateway from PC0 as well. PC1, now instead of pinging PC1, which is this computer, we're going to ping PC0. So go back to our chart. PC0's is this here. So ping 172.16.1.1. 1, 2, 3, 4 replies. Yep. It's not case sensitive, no. So that means you can use uppercase or lowercase. And last, for this step, on PC1, we're on PC1 still, ping the default gateway IP. So here's the default gateway for PC1. Let's do that with ping 172.16.1.2. Of course, you got to put it in right. 1.254. 1, 2, 3, 4 replies. We are good to go there as well. Huya? Any questions? All right, I'm going to stop there and have you figure out the rest. Huya? All right. So go ahead and log in and do packet tracer 6.1.2.1. All right, what do we think of that packet tracer? Fun? All right. Yeah, we got one more packet tracer we'll probably do in IT Essentials, but the rest will be in CCNA. In CCNA, yeah, your skills will be in packet tracer, but we'll talk about that in CCNA. Everybody good? All right. You want help? You can say no. All right, continuing on. 6122, network design. Now, your typical network in your house, your barracks, is going to be significantly different than an enterprise or a large corporate environment network. When you are just in your house, you probably don't need to know about access points, switches, routers, all that stuff. But if you're working with clients, designing large networks, you're definitely going to need to know about all of that stuff. And the design. Are we going to have redundancy, redundant paths, redundant links, et cetera, et cetera. Easy day? All right. Let's continue on down. And down, down, down. Selecting a NIC. What does NIC stand for? Network interface card. What does that allow us to do? Connect to a network, right? On the top left, we have a NIC. If we click on that, we can see that that is a wired Ethernet NIC. What's the IEEE standard? 802.3. Very good.
Yes.
Ethernet, right? And to the right of that, that's wireless. That would be which IEEE standard? 802.11. And yesterday we learned about all of these substandards for 802.11. Some that are 2.4 gigahertz, some that are 5 gigahertz, etc. If you're already forgetting those, it might be good to do flashcards, etc. Below that, we've got a USB NIC. We've seen that before. If your computer doesn't have wireless capabilities or even wired, you could install a NIC so that way you can connect to the network. Easy day? All right. Installing and updating a NIC. Now, each piece of hardware has what so it can talk to the software? A driver. Now, where are we going to configure those drivers at? Device Manager, right? So we can see this here. If we go to Device Manager, we've got all of these here. Then we can click on a specific device. Like if we go to Network Adapters and then select that specific NIC, if we click on that, we can open up the Properties. Within Properties, there's a tab for Driver. And within there, we have all the information. Who the manufacturer is, the date of the driver, the version. We can look at even more details, and we can update that driver from here as well, which is in Device Manager. Now, let's say we update this driver, and for some reason now our hardware doesn't work. We can roll back or go back to the previous driver that did work, that we knew was good, it was known good, and that's called rolling back the driver. Huya? We can also disable this piece of hardware here. and we can uninstall it as well. So disable, it'll be disabled, unusable until it's re-enabled in the same location. If we just want to uninstall that, we can as well. Questions?
Why would you need to disable and uninstall one?
That's a great question, right? So you might have USBs. When like thumb drives and stuff came out, people were plugging in USBs like crazy. Some computers in the government, you disabled those ports in software so you can't use them.
So you're saying you install the driver like on the motherboard, or is this like one of the ports? Like,
So drivers are software, right? And we have a driver for each hardware component. So it's the software that'd be installed for each hardware so it can be translated, so it can communicate, so that hardware can communicate with the operating system. That work for you, Grace? Okay. Anything else? All right, moving on. Configuring a NIC, we've already done that. Questions on this? No? Okay, well, we'll see this on Monday. We'll look at it. This is what it is for mobile devices, which we'll dive into again in Chapter 7 for mobile devices. Hooyah? Hooyah. Awesome. So when I say hooyah, you say hooyah back. That's kind of like a ping, right? When you ping on a computer, you ping an IP address. That's the hooyah. And then if they say hooyah back or that ping response, you know that that device is on the other side, right? So ping, the protocol for ping is ICMP. Remember, that's in the internet layer of the TCP/IP. So that's ping. Easy day? All right, let me demonstrate some stuff with ping for you. Oh, do I still have your computers? You're good. I'm going to sit back down. All right, to open up command prompt, I'm going to type CMD, unlike in our packet tracers we just did. Now, what's great about command prompt is you can ask for help. So I could just do ping, enter, and it knows I'm missing some options. Or I could do ping space / question mark. See this here? Enter. And it brings up all of these things here, right? I've got options that I can use with ping. Right? Like ping tac T will ping forever until it stops. So let's look at that. Let's do ping. And let's ping Google's DNS server. But if I put a tac T in front of here, it will ping continuously until it stops. There it is again. And it'll just go forever and ever and ever. This will be useful, let's say you're doing some troubleshooting. We saw that ping by default is how many times? 4 times. Well, if you're troubleshooting, making a change here, making a change here, you could have this be going in the background while you're doing things and be like, once it's back up, you'll know because it'll get a response. Does that make sense to everyone? So this will be useful, this ping tac T, for troubleshooting when it pings continuously. But how do we stop this? We'll hit Control C. Good to go? Okay, other options we have, we can do ping space / question mark. Let's see, other ones. We could do tac N, which is a certain number. N for number. How many do I want to send? By default, it's how many? 4, but maybe I want to send a specific number. So let's ping our loopback address. What's my IPv4 loopback address? 127.0.0.1. If I just do that, there's 1, 2, 3, 4. If I want to do it continuously, it's ping tac T, and then it'll just go 4, ever until Control C. But let's say I want to do it a certain number of times. Somebody give me a number. A number that we can see. 10? All right, let's do ping tac 10. Or sorry, ping tac n 10. 127001, which is my loop back. And there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 exactly. Let's do that again. Let's pick another number. 8. All right. Ping, tac n, 8. And let's do my loop back again. What's my loop back? 127001. There's 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense to everyone? What is it for continuous? Ping, tac t. There you go, and it'll just go forever. There's 1, 2, 3, 4, 5, 6, 7, etc., 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 until I hit Control C. What if I want to do it exactly 2 times? Ping, tac n, 2, and then we can do our loop back, 127001, or whatever IP address you're doing. There's 1, and there is 2. Huya? Cerna. That tests our TCP IP network stack all the way to our NIC, but not leaving our NIC. And just checking our computer. All right, we've got other options. Let's do ping space / question mark. I can change the timeout time. I can do TAC 4. That'll force it to use IPv4. I can do TAC 6. That'll force it to use IPv6. Cheng. That's a certain number of times. If you want to do it exactly 10, exactly 2, exactly 100 times, it'll do that.
Yeah, well, in what kind of situation?
If you've got testing requirements that say, hey, we need this ping, it's got to be exactly this number of times. So we know it's not just the 4. We want to have a consistent base. Good? Okay. I could also ping, instead of an IP address, I could ping a URL, cisco.com. And look at that, it translates it to an IP address. What protocol translates it to an IP address? DNS. Port number 53. TCP or UDP? Both. Questions on that? All right, let's watch a video.
To start, we will connect our computer's Ethernet. Hello everyone, it's time to get a computer hooked up to a network.
About 10 minutes.
In this video, we're going to do a wired and wireless configuration using our Cisco wireless router. To start, we will connect our computer's Ethernet port using a network cable to one of our LAN ports on the back. Take my computer's Ethernet cable and plug it into one of our LAN ports. Next, we want to get this wireless router connected to the internet. So I'll take my internet cable from my modem and plug that into my LAN port on the back. At this time, I can go to my computer's web browser and I can type in the IP address of my Cisco wireless router. If you do not know the default IP address of your wireless router, you can look it up in the documentation that came with it. Or you can use some command line tools on your user device. My wireless router has the default IP address of 192.168.1.1. I'll type it in and I'll click enter. Immediately, my wireless router asks for credentials. I will use the credentials I found in my documentation, which was a username of Cisco and a password of Cisco. Consult your documentation to find your credentials. I'll click on login. Immediately now, I can't do any configuration changes except to change the default password. The old password was Cisco, as we mentioned. I can see that there's some minimum requirements I need to follow, as well as a password strength meter down below. The password strength meter is not foolproof, but it does help you in determining password complexity. For the new password, I can type in something a little more complex than before, and I can get a password strength supposedly of strong. But again, how much do you trust these meters? They help though. With the new password selected, I'll click Save. And I know it's going to work because it's going to log me out of my wireless router and require me to log back in with my new credentials. I'll use the username of Cisco, and then my new password, and then I can click Login. And now we can actually configure our firewall router settings. To get started, we're going to take a look at the WAN settings. That's going to be inside of our networking section, and by default, we're in WAN. We see that the internet connection type is using DHCP for our internet addressing. Also, for our DNS addressing, we have that set to automatically get that as well from our ISP, our internet service provider. If we wanted to change this to utilize a static address, we could do so. If we wanted to change our DNS servers that we're utilizing to not be from our ISP, but maybe from Cisco's OpenDNS or other servers, we could also select that here as well. Besides our WAN settings, we can go over to the LAN settings, and in our local area network settings, we can see a lot of items that we can configure. To start off here, what we can see is the local address of our wireless router. This is the default address provided by the manufacturer of my router. If I'd like to, I can put in a new value here, and then click Save. Besides just changing the IP address on my wireless router itself, we can change the subnet mask, which controls the network size. Also, we have DHCP server settings. By default, my wireless router is acting as my DHCP server. Down below the DHCP server settings, we can see the starting address that we're giving out to the user devices, as well as how many user devices we're supporting with DHCP. The default on my router here is 50 devices. If I'd like to have more devices on my local area network, I can increase this number from 50 to a higher value, for example, maybe 100. As we continue on looking at our settings, what we'd like to take a look at here is, what if I didn't need the DHCP server on this router? What if I had a separate server running on my network? I can use my disable radio button to actually turn off DHCP on this device. When we talk about DNS settings, right now we're getting our DNS utilizing our WAN port and receiving it from our ISP. If I wanted to change what DNS server my users on my network are using, I can use the drop-down menu here for DNS, and I can have it used as below, where I can just specify multiple DNS servers for my user devices to target. So this has been great and awesome so far. What we want to do now is take a look at our wireless settings. I'm going to go ahead and click on wireless on the left side. I'm not going to save my changes. And our wireless screen loads up. Now inside of the wireless settings, one of the first things we'll take a look at is this enable checkbox. This says our wireless transmitter is turned on and wireless is running on this device. If you wanted to disable wireless on your device, you can uncheck that radio button, and it effectively makes our wireless router firewall just a router firewall. This will disable the wireless transmitter. This would come in handy if you want this to act as a router, then you have other devices on your network that are acting as wireless access points to provide wireless coverage for your enterprise network. For us, we want to keep the wireless on so we can continue with this video. Next, in the wireless network mode drop-down box, we can select which wireless to support. If we leave the default of BGN mixed, it's going to be a slower wireless network than going with GN mixed, or G only, or N only. For myself, I like to do...
What is he talking about there? What do those letters mean? Wireless, right? He's talking about the 802.11 standards, right? So it can change the frequency, the speed, the range, etc. Good? All right.
GN mixed, I'm not going to provide legacy support for wireless speed. Below that, we need to take a look at the wireless channel. We can leave this at the default of automatic, where the wireless router will determine automatically the best wireless frequency to utilize to avoid interference. If you wanted to statically set your radio frequency to use, we could do that here as well. But we'll leave it at auto. Down below, I have multiple wireless networks. I can deploy these on the wireless router all at the same time. By using the variety of edit buttons down below, I can change the wireless SSID, I can change the wireless password. I can even change the type of security for a wireless, as well as the maximum amount of wireless
pause again.
clients per wireless network on board.
So that SSID, that stands for Service Set Identifier. Have you ever gone anywhere and you've seen like, join a Wi-Fi network and it's FBI surveillance van number 1 or whatever people name it to, right? When you change your SSID, you're changing, right, what you're broadcasting your wireless name out as. Good? All right.
One. For example, if I click on the checkbox for the first wireless network of Cisco SB1, I can then click on the edit button down below. Immediately, I can change the wireless network name. Right now it's Cisco SB1. I can change this to Business Connect. Do I want the wireless name of Business Connect to be seen and visible by everybody? I can control that with the SSID broadcast button. Also on the far right, we can even control the maximum amount of clients allowed to connect, which I can change this to, for example, 40. When I'm done with these settings, I will click Save, and my wireless router is going to change Cisco SB1 to now be the name of Business Connect. Also, I'll be allowed to have 40 wireless users connected at a time. Next, if I select the checkbox for that wireless network again, and then I'll click on Edit Security Mode, it'll take me to a new screen. And in Security Mode, I can see my wireless name that I've configured, followed by the Security Mode dropdown. Right now, by default, we have WPA2 Personal. This uses the encryption of AES. This is more secure than choosing something like WPA2 Personal Mixed, which utilizes AES encryption and the legacy TKIP for backward compatibility. For us, we want the security mode of WPA2 Personal with AES encryption, which is more secure, and we will set up our password here. For example, how about this? Awesome. You want to see what it looks like? That's my password. Now I'll click Save, and this will create the wireless password that my users will need to type in order to access the wireless name of Business Connect. With the wireless network named and our wireless password created, I go to my computer's wireless settings, and I can see Business Connect is ready to be connected to. I can click on that, click Connect, I can put in that password, and once I hit Next, we should get a wireless network connection, and we are good to go. We are seeing this connected. We are accessing the radio frequency being sent off by my wireless transmitter on this wireless router. Now that we've completed this wired and wireless config walkthrough video, make sure you take the time to explore your own wireless router and try your hand at deploying a computer network. Thanks for watching.
What do we think? Pretty exciting?
Yeah.
Questions?
Does that mean that we could do that with the Go Wi-Fi?
Yeah, we'll talk on Monday how most, right, because these are private. You notice that was a 192.168? That's a private address. So that means what you can do is in fact, Davia, go ahead and open up another tab, type Google. Type Go Wi-Fi router IP address. Go Wi-Fi space router ROUTER space PASSWORD. Enter. RD, enter. Oh, there you go. Look at that. Not only do you have the IP address, but you've got the typical password as well. So yeah, and you just go into a web browser, you can do that, and you can get into devices. Now, unauthorized access, you have to follow laws and things like that. Good? Any other questions? How are we feeling?
I have a question. So if like you were to do what you just did with like your Wi-Fi, you have to connect the computer to the Wi-Fi box, or could you do it just by searching up
You'd have to be on that network because it's private, right? That router does have a public one as well, but if you're connected wirelessly or wired to that network and you've got that IP address and the default credentials, you can get into it. Good? We had a good Friday? We want to stop there?
Yes.
All right.